name is Gabby Bailato. I'm a Solutions Marketing Engineer here with Keysight Technologies. Today I'll show you how to efficiently use the memory in the UXA signal analyzer to capture a pulsed radar signal. Due to long scenarios with dynamic pulse trains, memory can run out quickly. We'll use gated acquisition and recording capabilities to fully utilize the allotted memory of the analyzer. Let's take, for example, this simple pulse signal. It has a PRI of 100 microseconds and a pulse width of 3 microseconds. The most amount of measurement time that we can capture in one single acquisition will be based off of the sample rate and our memory size. So for example, if we have a sample rate of 100 megahertz and a memory size of 5 megasamples, the most amount of time we can capture is 50 milliseconds. With a PRI of 100 microseconds, this results in about 500 pulses. With long PRIs, that means there's a lot of dead time in between pulses, which the analyzer is also capturing and using memory on. We can use gated acquisition to only capture the on time of the pulses so that we can capture even more. We could set the gate length to 3 microseconds because that was the length of our pulse widths. And we will leave a start and stop delay of 1 microsecond. What this means is that we will capture 1 microsecond before, 3 microseconds of the on time of the pulse, and 1 microsecond after, for a gate of 5 microseconds. The analyzer will continue to capture pulses until the specified amount, which we will set to 50. Once we turn the gated acquisition on, you can see that the analyzer has only captured the on time of the pulses. We've also kept track of the pulse width and PRI and other pulse statistics. If you recall, we could capture up to 50 milliseconds worth of time. If we're only capturing 5 microsecond segments, that means now we can capture up to over 15,000 pulses. Now that you understand how gated acquisition works, let's switch gears to a more complex signal. Take a look now at this bursted pulse signal. The PRI in between pulses is still about 100 microseconds, however there's a dead time of 1 millisecond in between each burst. With long dead times like this, we would capture even less pulses with normal acquisition. Also notice that the pulse width is varying from 1 microsecond up to about 10 microseconds. With the settings we used before with a fixed gate, we would still be able to capture some of the pulses, but we would miss the ones with a wider width. Instead, we can use a variable gate, which looks for a rising and falling edge of the pulse and sets the gate length accordingly. You could see here, we've captured the same amount of pulses as our previous signal, but with a variable segment length rather than the fixed gate. After you set the correct sample rate and gate sizes, you can switch the analyzer over to the scatterplot mode to do statistical analysis. For example, these two scatterplots reveal how the pulse width and PRI vary over time. We can see that there is a 1 millisecond repetition interval in between bursts, and you can also see that the pulse width is increasing within that burst. Scatterplots and other statistical analysis tools can be very useful when you start to capture thousands to tens of thousands of pulses. We can use this gated acquisition technique with the record and playback capability of the analyzer for deep memory acquisition. To do this, we will set the analyzer to capture 50,000 pulses and set the analyzer to record mode. After the recording is finished, we can switch over to the playback configuration window to view what we've captured. On the left-hand side, we can see the pulse descriptor words listed in the table, and we can also see the pulse density captured on the right. We can use the slider at the bottom of the display to select a piece of the recording to view and analyze. For example, we will look at about 800 milliseconds of the recording in 5 millisecond segments. Then we can switch back to the scatterplot mode and step through each segment for a closer look. Finally, once we're satisfied with the captured data, we can then save it into various format types for further analysis. Here's an example of some of the format types that we can save. It could then be recalled back into the analyzer for further analysis or with other software tools. Many times, in radar and electronic warfare applications, signals can last on the orders of seconds. Today I've shown you how to use gated acquisition with record and playback capabilities to best capture your signal under test using the UXA Signal Analyzer and Pulse Analysis application. For more information, please visit Keysight.com or contact your local Keysight representative. Thank you for listening.